use synthetic division to factor and solve the equation. So remember, when we think about all of our choices, we first would list all of the multiples of the constant back. In this case, it'd be 1, 2, 4, 7, 14, and 28, divided by all of the factors of the leading coefficient. 1, 2, 3, 4, 6, 8, 12, and 24. Now, if I was going to put these all up, there would be a lot. Because first I'd start with the integers, positive, negative 1, positive, negative 2, 4, all the way to 28. Then I would divide by 2, so I'd have 1 half. 2 over 2 reduces to 1. 4 over 2 reduces to 2. 7 halves, positive and negative. 14 over 2 reduces to 7. 28 over 2 reduces to 14. And you understand, then I'd have positive, negative, 1/3, and so on. Okay, so now in this, I was able to first, let me actually go back to these windows so you can see what it looks like. So the first thing I did is I plugged this into my graphing calculator. I plugged it in, you can see my windows, and I graphed it. Now, Mr. McFarland said in his video, for synthetic division 2, you're able to identify one of the roots using the graphing calculator. So I'm going to identify, it doesn't matter which one, but I'm probably going to identify this, one of these, doesn't matter actually which one I do. So this is the way I'm going to do it. I'm going to go second trace 0. And if I do this one right here, I can see it's between 0 and 1. So my left part is going to be 0, my right part is going to be 1, and then I just press enter again. And I can see that one of the roots is at 0.25. Now, if you didn't know what that is, you type in 0.25, you hit math on the left-hand side, and you press enter twice, and we can see that 0.25 is the equivalent in fraction form to 1/4. So I'm going to start by testing 1/4. And I know it's going to work. I know it works because it's a 0. Second trace value, 0.25, it's a 0. Now you absolutely must show your work. So the highest degree is 3. So I have a coefficient for 3, a coefficient for 2, a coefficient for 1, and a coefficient for x to the 0. I know this is going to work. Why am I doing it? Because the results down below will help me to build a quadratic equation where I can use either I can use factoring or the quadratic formula in order to solve. So here we go. I'm going to grab a pencil here. I'm going to drop down the first number to get 24. Now, how do we think of this? 1 times 24 is 24 and divided by 4. So think of 24 divided by 4, easy. 24 divided by 4 is 6. All right, combine to get negative 52. Now, negative 52 divided by 4 is negative 13. Dividing to get negative 112. So I'm going to take 112 divided by 4, and a negative divided by a positive is a negative 28, and we can see it works. That's no surprise. I knew it was going to work because 1/4 is in fact an x-intercept, which means that the output or the y value would be 0. Makes sense. What do I do with this? So negative 112, negative 52, and 24. No x's, 1x, and 2x. Now, that's way too big of numbers to work with. When I look at this, I believe that I can factor out maybe even, I know I can factor out a 4. Is that the largest number out of all of these? I believe it may be. Let me check here. I believe 4 may be the largest. Let's check. Divide by 4, I get 6x squared minus 13x. 112 divided by 4 is 28. Minus 28 equals 0. Now, off to the side, I can either use quadratic formula or I can try factoring. That's really up to me and what I choose to do. These look, I don't know, they look pretty big numbers. I don't know if I can factor this, and I could take time in trying. I think I'm going to just jump right into the quadratic formula. X equals, so it's a negative b, but the b is already negative, so 2 negatives make a positive. And then it's going to be b squared minus 4ac, all divided by 2 times a. A, B, and C. Don't get distracted by the 4 that's been factored out. A, B, and C. Okay, x equals positive 13. Now, I know 13 squared or negative 13 squared is a positive 169. Then I have negative 4 times 6 times a negative 28 to give us a positive 672, all divided by 12. Do you need to see all of this work? Absolutely. 169 plus 672 is 841 divided by 12. Now I need to see, can I break 841 down? That's a must. I must be able to do that. So I'm taking this out and I'm trying. 841, let's see, what can I break this into? And I'm just going to start trying kind of in front of you to see what we can do here. So 841, and I'm going to go by the squares that I can think of off the top of my head. So let's see. I'm going to divide it here by, let's go 6 squared. That doesn't work. Let's go 841 divided by 15 squared. Ooh, that doesn't work. 841 divided by 14 squared. That doesn't work. 841 divided by 13 squared. 841. I know 12 squared, by the way, is 144. 841 divided by 11 squared. 841 divided by 10 squared. Oh, goodness. 841, let's see, 10, 9 squared. 8 squared. 7 squared. Oh, goodness. Maybe I should have done a larger number. I started with 16. I may have had to start with a larger number is what I'm thinking. So 7 squared, 6 squared. Oh, gosh. 841 divided by 25. Okay. Divide, that's 5, 4, 3. That's not going to work, and it's not going to work. Okay, so I should have done larger numbers. Let me break this apart into larger numbers. I started with... Okay, I'm an idiot. I should have just taken the square root of 841. I assumed that it was not a perfect square because I was not familiar with it. The square root of 841 is 29. All right, so let me come back here. The square root of 841 is 29. There's no need for me to try to continue to break those up. So x equals 13 plus or minus 29 over 12. Okay. Remember, I only have one of the 3 roots, and that is 1/4 at this time. So I know 1/4 is one of the 3 roots. So one time I'm going to add, and then I will divide by 12. So I'm going to grab a calculator. 13 plus 29 is 42, and you can see that on my calculator. Now I'm going to divide it by 12, and then I can use the calculator to reduce it into 7/2. Another answer is 7/2. This time I'm going to subtract. So I'm going to take 13, subtract 21, divided by 12, turn it back into a fraction to get a negative 4/3. All the work is necessary.